talk to my students about rates of mutation, and that rates of mutations accumulating fast enough to wipe out species. Even evolutionists admit that mutations are wiping out species, that they can't last very long just because of the accumulation of unfavorable mutations. And they've never really had an answer for that. They just hope nobody else finds out about it. Well, at the conference I was at, a John Sanford, a Cornell geneticist, came up to me and he said, I wonder, does that set an upper limit on the age of the Earth? Just mutation rates, a biological rate limit, age limiter. And I said, I've been thinking about that too. I said, but I don't have the math to follow it up. I tell my students, hoping they'll do all the hard work. Well, he said the same thing. He had more background than I did. But he said, I need some math help. Well, guess who showed up at ICR about that time? John Baumgartner, who you'll hear would be the first science speaker tomorrow. He's the one that ran the Cray supercomputer system for Los Alamos National Laboratories, the one who does the computer modeling for plate tectonics. ICR now has a supercomputer array that Baumgartner dubbed Epiphany, and so he can handle all these low probability calculations and things like that. And so John Sanford is now working on that. He has a book out, and I forgot the title of it. Anybody remember the title of John Sanford's book? It's really good. Genetic entropy. Yeah, in fact, I used to call it that myself. And so decay, the second law of thermodynamics you guys were talking about, it applies to everything, including genetics. And so I think you're going to have some fascinating material out of that. They're also looking at DNA from fossil remains of Neanderthals and things like that, and human beings from different cultures. How fast do variation, not mutational decay, but how fast is variation spread? And it's, of course, it looks like from the preliminary data, orders of magnitude faster than the evolutionists ever imagined. Everything happens faster than the evolutionists imagine. And so that's kind of exciting. So we may be able to share some of those things in the future. But in the meantime, there's some exciting things here. What reminded me of this is that Rob Carter, who's working on the Gene Project, found 11 of these scutes together, with already put together. You didn't have to glue them together, about a 20-minute walk from our back porch. And so you never know when you're going to find something really spectacular like that. He donated them. We have them on display there in the museum. Mary, we've been to the London Museum, the British Museum of Natural History, and Mary got a picture, but I don't have it with me. It's in the PowerPoint presentation that I also don't have with me. Her next to that complete one. You also find, Frank Garcia has been good at reconstructing whole animals. And so in Florida, Florida's kind of fun anyway. It's a different kind of fun than Colorado. And so you have llamas, camels, rhinos, horses, big horses, little horses, a giraffe with 6 horns on it, and some odd species like that. Mammoths, mastodons, giant ground sloths bigger than T-Rex. Of course, mammoths and mastodons are much bigger than the average dinosaur. And so you have just all kinds of stuff like that down there. And you can find interesting pieces. Here's one of our students has found the astragalus, the pulley bone, the tendon for these animals like deer. There's lots of deer and llama. As they can jump like that, they need to have that tendon slide in the groove. And you can Mary can, tell you what animal the astragalus came from, that pulley bone there. And in this case, it's from a little horse. And in Florida, in fact, in DeSoto County, where Arcadia is, we have horse breeders that have got horses down to 17 inches in height for a mature horse, full-grown horse. Well, how do you tell the difference between a little horse and a newborn baby big horse? And the answer is, that growth plate, epiphyseal plate. If it's not there, it means it's a full-grown animal in the case of a mammal. And so this is a full-grown little horse. Well, here's another common Florida resident. Okay. And the good news is the alligators in Florida are real Southerners. Okay, laid back, just lie in the sun, watch the tourists go by. Okay, they're not about to get up and attack you. Okay, that's way too much work. And so, praise God, we've never had a serious alligator encounter, negative encounter. They're kind of fun, just to see them. But we also find their fossils there. And so fossils of alligators are kind of fun to find. Again, they have armor plating, and so the alligator skewed a section of armor plating. Very distinctive, has a little mountain in the middle that sticks up as a blunt spine on the back, and you can find different bones, vertebra, petrified alligator poo. Danger. Not all of the alligator poo is petrified. Okay. Well, you may have noticed the transition there from lots of land animals, horses, elephants, giant ground sloths, giant armadillos, llamas, camels, all of this stuff, to, semi-aquatic alligators, and things like that, to regular sea creatures. And so here's a manatee, although technically the fossils are dugong. There are two varieties of sea cow. This is, a live one, an underwater picture of a live one. But their rib bone, we have a whole skeleton except for the skull. There's only 3 skulls have ever been found, but there's so many manatee ribs, and some of them are this big around and this long. Have been found that one scientist quipped that, if some ray gun could magically make all the manatee ribs disappear from floor to soil, the state would be underwater. So there are gobs of them out there. Mary lets kids plaster jacket them and take the specimens home. And of course, she runs out of specimens. So there's a place I can go with a 5-gallon bucket and fill it up in about 10 or 20 minutes. And lots of these things. And they're fun to find. The skulls are kind of hard to find for 2 reasons. One, skull bones tend to be odd shaped except for the lower jaw, and they tend to come apart. They're filled with air spaces to make the skull lighter typically, and even in the manatee. And so they disarticulate, they separate, and they crush, and they have funny shapes that people don't recognize. Although Mary did. She found a piece of a manatee skull near where we pick up all those rib bones. We find a fish vertebrae of a variety of kinds. Find some interesting parts of coral crushing fish. A sea robin is a fish that looks like this. It's got a real heavy plate on the front of its nose, and it runs into coral and can crunch up coral like that. There are a number of coral crunchers. And pufferfish and parrotfish can crunch coral, and you see their mouth plates in there. You see ray mouth plates, stingrays, manta rays, eagles.